Okay, welcome back. This is Giancoli chapter 14. We're going to be looking at example 14.8, which is the heat loss through a window. So this is very typical in a house. We've got the temperature inside the house. It's colder outside. What happens is you have a heat flow across here, which is some power going across, which is just my heat per time, or if you prefer, we're going to use this formula. So what do we know? We know that this is the formula for the heat flow, energy per time. That's our wattage. A K is our thermal conductivity. So we've got a glass window. We're going to use joules, seconds, meters, degrees C. We've got our area that tells us 3 meter squared window, so a very big window. Change in temperature, it's going to be 1 degree, and my width of my substance is 3.2 times 10 minus 3, so about 3 millimeters. So that's how we calculate. So let's calculate this for the heat flow across here. What we want to do is, we want to say the power that we're lost, or the heat per time, is K, so that's 0.84. Let's get our units here, joules per second meter degree C, times my area. Oh, am I going to run out of space? Maybe. Meter squared, times my temperature difference, 14 minus 1. And let's write it down here, so it's 15 degrees Celsius minus 14 degrees Celsius. Kind of have to go to the second line here. Times, or divide by that whole thing. That's going to be divided. That's hard to see. Put this here. Divide that whole thing by my width, which is 3.2 times 10 to the minus 3 meters. Okay, so let's write that again so it's clear. 0.84 joules, seconds, meters, degrees C. That's my units. 3 meters squared times my temperature difference is going to be, I'm going to write that down as 1 degree Celsius. Oh, and I got another sig fig. Divided by my L, which is the 3.2 times 10 to the minus 3 meters. Now let's check units. So the meters here, there's a meter here, there's a meter here, that's going to cancel the meter squared here. My degrees Celsius, there's my degrees Celsius, cancels. So I'm left with joules per second. Perfect. That's what my units of power are. So let's do the calculation here. My calculator, 0.84 times 3 for the area, 1.0, I think it's 1415, that should be a 1.0 degrees times, and then divide by the width, 0.84, 3 times 3.2 e to the minus 3, and divide that. We find that it's 787.5. You can 787.5, getting ahead of myself, but we really only have 2 sig figs, so we're going to round to there. So this is a 5 or greater, yes. So this becomes 790 joules, not joules, joules per second. We could also call that 790 watts of power that's being lost through that window.